Hello. So this is Physics 2211 Lab 3, and I'm Alex Rangel. Uh, if I'm kind of hard to understand right now, it's because I'm really sick while recording this. So let's get going. Introduction. The purpose of this lab is to determine the mass of a theoretical black hole and the needed velocity of a spaceship to escape the black hole. In the models, it was found that the black hole was 8.46 times 10 to 1033 kilograms and to the 33. That should be 10 to the 33. And the spaceship needs to have a velocity of negative 4.2 times 10 to the 7th, 7.5x times 10 to the 6th, 0 meters per second. The fundamental physics models used in this lab are Newton's second law, force of gravity, and curving motion. So we got force of net, perpendicular, parallel, force of gravity, and then force net again, because I put that in again. This lab was conducted purely computationally, meaning there's no real-life model. First coding model is to find the mass of the black hole created. This was calculating by modeling a star that orbited the hole and working backwards using the Newton's second law of force due to gravity and curving motion principles. In this model, the system is the star and the surroundings is the black hole. The second coding model is to find the initial velocity needed for the spaceship to escape the gravitational pull of the black hole from the first model. In order to use this, Newton's second law, the force due to gravity, and kinematics principles are used. In this model, the system is the spaceship and the surroundings are the planet and the black hole. Alright, so this is the code, and these are the conditions of the model. So we got the star, and we got like dp over dt and stuff like that, you know. Here's this. This is the conditions of Model 2, by the way. This is the code for Model 2 and results and conclusions. In the beginning of this lab, the mass of the black hole was 8.46 times 10 to the 33 by taking the average of every calculated mass over each iteration. For second part of the lab, the initial velocity of the spaceship needs to be negative 4.2 times 10 to the 7th, 7.5 times 10 to the 6th, 0 to pass the black hole while still being able to leave the system. Possible error in this lab can come from possible physics errors. So what does this mean? This means that the rate of change of momentum and net force are the same thing. The equation dp over dt equals Fnet is the change in momentum over change in time is equal to net force. This is Newton's second law. And then for the what if, for the spaceship to somewhat have an orbit, the needed velocity is around negative 2.2 times 10 to the 6th, 7.5 times 10 to the 6th, 0 meters per second. And this was the planet's orbit speed, the planet's orbit period, and all that. And yeah, that should be it. Thank you.